So hello again, everybody. I hope everyone's capstone went very smoothly, and I hope that you guys will enjoy our presentation today. We want to say thank you to take the time to view the outcomes of our semester-long of effort, and I hope it's of interest to everyone present. Special thank you to anyone from outside of state that took the time to come here today. We really appreciate that, and we hope you enjoy it. We are the 4 members of the injection molding capstone team. We have myself, Caden O'Shea. We also have Brant Lee, Aiden Lassaline, and Brandon Marshall. To review quickly, our objective was to provide a machine that could injection mold type 6 plastics into a usable product, as well as have easy implementation into any sort of developing country that needed it. So as per the group before us, we'll have a question and answer period at the end, so please hold any questions you may have until then. To start off quickly, I'll just run through our agenda. We are going to split the presentation into 2 sections. The first little bit for about 2 minutes is just a brief review of all the stuff that we covered in the first presentation to catch anyone up to speed who either was not here for the first presentation or just needs a little refresher. So we will run through the problem statement, the scope, and then we'll have a brief overview of kind of where we started with the first presentation. We'll then move on to some things that we feel are crucial to the understanding of the project, which is the bill of materials, our house of quality, a bunch of CAD design we did for the hopper systems and whatnot. Then Aiden will take it away with our PLC, our wiring, and our implementation of that. We'll then have a brief demonstration in the form of 2 videos, just showing the processes and whatnot of our machine. And then, of course, we'll move on to that conclusion and any questions, comments you guys may have. Thank you very much. I hope you enjoy.
Alrighty, so starting off with the problem statement here, it arises from the use of single-use plastics, and that roughly 79% of the used plastic we use as a race is currently in landfills. And as you can see on the graphic on the right, a lot of this plastic does not decompose quickly or at all, or it could take centuries. And so designing this injection molding machine that uses shredded and cleaned recycled plastics is a very important project, we thought. And as well as we want the control unit to be an independent system, so it can be sold to whoever needs it, and the rest of the machine itself, the piston, the hopper system, anything else can be thrown together using scrap materials or resources they have around themselves. The scope for this project entailed creating the injection molding machine with integrated PLC and HMI control, as well as designing and installing a hopper and weighting system for plastic, as well as we created full project documentation, including things like bill of materials, house of quality, any housekeeping, things like that, as well as electrical and pneumatic schematics, and a full technical report on our thought process and how we arrived at our decisions, as well as why those decisions are beneficial and need to be taken. I will now hand it off to Brandon to further explain.
All right, so where we started. So this slide contains various ideas that we use to help our design process. And if you look at figure 6 and figure 7, they contain some of our various design concepts we are going to integrate into our hopper system and transportation of the plastics. Figure 8 is our functional analysis diagram, which aided in designing the actual process of the injection molding machine. And finally, figure 9 is our morphological chart, and this was used to help us find different and efficient ways to properly design solutions of the machine. So for bill of materials, we tried to find parts that closely resembled the actual parts on our injection molding machine, as lots of the parts were outdated and prices were difficult to find. We discovered that an alternate supplier would be more cost effective for the majority of the time. We tried to stay away from suppliers like Amazon because their inventory changes when there is not a high demand for the part. And we determined that if we were to charge $100 an hour for labor with an estimated 364 hours of labor, that the total labor cost would be around $36,400. We determined that the total cost of the machine would be just under $2,000, so the total cost estimate would come to $38,360. The house of quality was important in figuring out what we believed were the most valuable requirements to integrate into our injection molding machine. We ranked safety and easy to use/learn as the most important aspects of the machine, as we want to keep the operator of the machine safe from moving parts and protection from the heat element. And as Dan can tell you, it gets very hot. And also, we want to allow anyone who wishes to use the machine straightforward commands that can be done by just touching their smartphone. Fortunately, these requirements both have a majority of strong connections to functional requirements.
All right, this CAD design is a flushed out model of our hopper and weighing system. It's designed to be 3D printable where possible, so the materials can be sourced. If they can't be 3D printed, they can just be replaced with scraps, as in like a bucket or a repurposed 2-liter. But it's designed to be used with a stepper motor to control the carriage down there. And then the carriage is equipped with a scale to determine either good or bad weight of dispensed plastic. And then the carriage is equipped with servo controlled doors on the front and the back to control whether the plastic is either rejected or accepted. If it's accepted, it will go down that little chute into the heating chamber itself. If it's rejected, it can exit through the back into a discard receptacle, whatever the operator determines to be useful or beneficial to them. External mounting for some of these pieces will be required. Other than that, you will see a fully fleshed out demo and video of this thing in use from Aidan, and I'll pass it off to him.
So first, our PLC. Shown on the left here is a picture of our PLC that we have inside of the case and controls the injection molding machine. The middle photo is a legend of our terminal blocks, so anyone can quickly locate any needed wires inside the case. And the photo on the far right is for the electrical diagram, so future groups can quickly see our thought process and locate wires for external devices quickly. Overall, our PLC is complete. We have it functioning and wired up completely as intended, and we are able to regulate and control the heat of both the nozzle and the barrel under 250 degrees Celsius. As well, the PLC can control our pneumatic solenoids, which allows for actuation of the piston through code. Our first video here is of our CAD design for our hopper and weighing system. As Brant mentioned earlier, it consists of 6 hoppers, 1 for each type of plastic. And when the operator selects what type of plastic they will use, the bucket will be moved to the correct type and will be filled with the plastic. If the correct weight of plastic is detected, the bucket will release the plastic into the slide for the injection molding machine. And if the weight is not good, it will kick it out the back and will be returned to the hoppers. Our second video is demonstrating the operation of our pneumatics to drop the piston and raise it, as I mentioned before. This process is being controlled through the PLC using a piece of test code we made up to run in a loop. The PLC opens the safety valve, allowing for air to leave the annulus area, which is the bottom side of the piston, and filling the cap end, the top side of the piston, causing it to lower. Then the PLC waits a few seconds and closes the safety valve and stops air from filling the cap area, while allowing air to flow into the annulus area, this causing the piston to raise back up. The safety needs to be opened before lowering the piston because as a safety feature, we do not want any chance of the piston dropping while an operator has their hands in the machine.
So to summarize, our group came extremely far in our progress, and I would say we are all very proud of what we have done. Our aim again was to reduce these single-use plastics in the environment with a low-cost system that could be implemented into these developing countries. We feel as though we made great progress throughout this semester in this long journey, and we hope it was of interest to you guys. Thank you to all staff involved as well who made this learning opportunity possible for us. We are very grateful for that. Now, if anyone has any questions, we will gladly take them now in our short question and answer period, as well as feel free to take a look at our trifold there, just a short little graphic of everything we covered in our project. Thank you very much.
Is there anybody with questions or anything?
No worries. Oh, there might be one in the chat there. I don't know if I can open it while I'm screen sharing.
No questions. Greg was just saying good to see an update on the machine.
Perfect. Awesome. Well, if there's no questions.
Yeah, I have one.
Go for it, Chris.
Yep.
Go for it.
So what do you think was the thing that you learned the most in this that we did not cover in the program? We gave you a whole bunch of tools, but you're doing something a little bit outside, i.e. plastics. What do you think your greatest learning was on this?
Personally, I think the greatest learning experience was working with the PLC itself, setting up everything that it needs, from power, from learning the new code for this PLC, as well as setting up all the I/O devices, the little nuances, things like that. We learned about how PLCs work and their little nuances, but to get hands-on experience with assembling a machine like this, I think that's where I learned the most, at least personally.
I think Brent took the words right out of my mouth. I was going to say the same thing. Physically wiring the PLC and whatnot, and also the pneumatics as well. I dealt a lot with those. The experience of actually using it and troubleshooting it, not in an online, like a simulated one, but a physical one that you could actually troubleshoot, was kind of took the learning to a whole new level for me. It was so much more in-depth feeling, which was really great. And I actually think that's very valuable for the future.
Oh, it's like I almost paid you for those answers. Those are the sorts of things I like Olga to hear. But the value of
You're welcome, Chris.
doing it physically, and the invaluable experience that gains you. Well,
yeah,
thank you
all
very
jokes
much.
aside, I think that was the best thing outcome of this. It was amazing.
I have
Awesome.
one more quick comment if we have time.
For
Yes.
sure.
Awesome. Lane Van Hartfeld again from Big Chief Snacks. Hopefully you guys can hear me okay.
I can hear loud and
honest-
clear. Thanks for coming.
Perfect. I just wanted to say great job on actually displaying the documentation you guys had as well. Coming from a maintenance standpoint, where I'm at right now, trying to have documentation on stuff that's actually valid and reliable is quite hard to come by, or if it is, it's in German. Thanks, Greg. Greg James, that is. So yeah, I just want to say I was really happy to see that.
Awesome. We really appreciate that. All that feedback is really nice as well. Perfect. Well, thank you guys for taking the time. Thank you for all the opportunity, everything, and have a good one.